For centuries, the aircraft carrier has reigned supreme at sea, serving as the backbone of naval power for many nations. These floating fortresses projected power across vast distances, enabling countries to exert their influence far from their own shores. They were symbols of national might, representing technological prowess and military strength. But what if the carrier could defy gravity itself, taking naval power to new heights, quite literally? Imagine a fortress in the sky, a behemoth soaring above the clouds, unbound by the limitations of the ocean's surface, capable of reaching any corner of the globe. This is not science fiction. This is a vision rapidly becoming reality. This is the future of naval warfare, where the sky is no longer the limit. The United States is developing a multi-billion-dollar flying aircraft carrier, a project that promises to change the face of military strategy. This technological marvel promises to revolutionize warfare, offering unprecedented capabilities and strategic advantages. It will redefine naval power projection in the 21st century and beyond, setting new standards for military operations. The flying aircraft carrier is not merely an upgrade, it represents a fundamental shift in how we think about naval power. It is a paradigm shift, a leap forward in military technology and strategy. Traditional carriers are powerful but inherently limited by their dependence on the sea. They are vulnerable to attack, and their operational range is constrained by the need for resupply and maintenance. They require vast logistical support, including fleets of supply ships and complex refueling operations. The flying aircraft carrier transcends these limitations, offering a new level of operational freedom. It operates in the open skies, free from the constraints of the ocean, with the ability to maneuver and deploy forces with unprecedented agility. This gives it unparalleled mobility and range, allowing it to respond to threats and opportunities anywhere in the world. The impact on warfare will be profound, ushering in a new era of strategic possibilities and redefining the future of naval power. The dream of a flying aircraft carrier is not new. This idea has been floating around for decades, capturing the imaginations of many. Science fiction writers and military strategists have long imagined such a craft. Their visions often depicted a colossal airborne fortress capable of launching and recovering smaller aircraft. In the early 20th century, concepts emerged. These early designs were often rudimentary, but they laid the groundwork for future innovations. Some envisioned blimps carrying small planes. These airships were seen as potential mobile bases, floating high above the battlefield. Others imagined massive flying wings. These designs were more ambitious, envisioning enormous aircraft with the capability to carry multiple smaller planes. These early ideas, while ambitious, were constrained by the technological limitations of their time. The materials and propulsion systems simply weren't advanced enough to make these dreams a reality. The birth of the modern flying aircraft carrier concept can be traced back to the early 21st century. This era saw a resurgence of interest in the idea, driven by new technological advancements. Rapid advancements in aerospace engineering, materials science, and propulsion systems opened up new possibilities. These breakthroughs made the concept more feasible than ever before. Military strategists began to seriously consider the potential of a flying carrier. They saw it as a game-changing asset that could revolutionize aerial warfare. Think tanks and defense contractors started exploring the feasibility of such an ambitious project. They conducted extensive research and feasibility studies to assess the practicality of the idea. What began as a series of theoretical discussions quickly evolved into concrete proposals. Engineers and scientists collaborated to refine the designs and address potential challenges. Advanced computer modeling and simulations demonstrated the potential of a flying carrier. These tools allowed for detailed analysis and optimization of the designs. This led to the launch of a classified development program by the United States government. The project aimed to turn the long-held dream of a flying aircraft carrier into a reality.
The sheer scale of the flying aircraft carrier presents unprecedented engineering challenges. The primary challenge is overcoming gravity. The craft needs to be light enough to fly but strong enough to carry a significant payload of aircraft, weapons, and personnel. This requires a revolutionary approach to aircraft design. Engineers are drawing inspiration from nature. They are looking at the structure of bird wings and the aerodynamics of soaring birds. Advanced materials like carbon nanotubes and graphene composites are being used. These materials are incredibly strong and lightweight. The design also incorporates cutting-edge aerodynamic concepts. This includes advanced wing shapes and boundary layer control systems. These innovations minimize drag and maximize lift, making sustained flight possible. Constructing a flying aircraft carrier requires not just innovative design, but also a revolution in materials, science, and engineering. Traditional aircraft materials like aluminum and titanium are simply not strong or light enough. To address this, scientists and engineers have developed entirely new materials specifically for this project. These materials have never been used before in aircraft construction. Carbon nanotubes, woven into composites, form the backbone of the carrier's structure. These materials are hundreds of times stronger than steel, but far lighter. Graphene, another wonder material, provides unparalleled strength and conductivity. This is crucial for the carrier's advanced electrical systems. The manufacturing process is equally impressive. Giant three-dimensional printers, some larger than football fields, are used to fabricate major structural components. Section 5. Flight of the Future. Propulsion and powering the behemoth. Powering a flying aircraft carrier is a monumental task, one that pushes the boundaries of current aerospace engineering. It requires a propulsion system unlike anything ever seen before, a marvel of modern technology and innovation. Traditional jet engines, while powerful, are not fuel-efficient enough to keep such a massive craft aloft for extended periods. They simply consume too much fuel. The solution lies in a hybrid propulsion system, a combination of different technologies working in harmony. This system combines the raw power of advanced nuclear reactors with the efficiency of electric-powered ducted fans, creating a synergy that is both powerful and efficient. The nuclear reactor, miniaturized yet incredibly powerful, provides a near-limitless energy source, ensuring the aircraft can operate for extended durations without the need for refueling. This eliminates the need for refueling during missions, allowing the aircraft to stay airborne for much longer periods. The reactor's energy is then converted into electricity, which powers a series of massive ducted fans strategically placed along the carrier's wings, providing the necessary thrust. These fans provide thrust for takeoff, landing, and maneuvering, ensuring the aircraft can handle a variety of flight conditions with ease. The hybrid system ensures the carrier has both the power and endurance to fulfill its strategic objectives, making it a formidable asset in any military operation.
Section 6. Trial by Fire, Testing the Limits of a Flying Carrier. Before it can take to the skies, the flying aircraft carrier must undergo rigorous testing. This is a crucial phase in its development. These are not your typical test flights. Given the carrier's size and complexity, engineers have devised a multi-stage testing process. This process combines sophisticated computer simulations with real-world flight tests. Initial tests focus on individual components and subsystems. This includes the propulsion system, flight control systems, and advanced materials. As the testing progresses, larger sections of the carrier are assembled and tested. This culminates in the first full-scale prototype taking to the skies. These tests push the carrier to its limits, gathering valuable data that informs further refinements and ensures its operational readiness.
Section 7. Wings of War. Operational Capabilities and Strategic Impact. The flying aircraft carrier, once operational, will fundamentally alter the nature of naval warfare. Its operational capabilities are unprecedented. It can launch and recover a variety of aircraft, including fighters, bombers, and surveillance drones. This gives it unmatched flexibility in combat scenarios. Its ability to fly above weather patterns and traditional air defenses makes it incredibly difficult to detect and target. It can strike deep into enemy territory with speed and precision. Its mobility allows it to respond to global crises much faster than traditional carriers. The strategic implications are profound. It enhances the U.S.'s ability to project power globally. It also acts as a powerful deterrent against potential adversaries.
Section 8. The Shape of Wars to Come, Future Roles and Evolving Warfare. The flying aircraft carrier is not merely a weapon, it is a platform for the future. As technology continues to advance, so too will the carrier's capabilities. Future iterations may incorporate directed energy weapons, hypersonic missiles, and advanced artificial intelligence systems. It could serve as a command and control center for drone swarms, coordinating complex air and sea operations. Its ability to access remote areas could prove invaluable in humanitarian aid and disaster relief efforts. As warfare evolves, the flying aircraft carrier will adapt, ensuring the U.S. maintains its technological edge in an increasingly complex and dangerous world.
Section 9. A testament to human ingenuity, reshaping global power dynamics. The development of the flying aircraft carrier is a testament to human ingenuity. It is a symbol of our relentless pursuit of innovation. This engineering marvel is pushing the boundaries of what is possible. It is redefining the relationship between humanity and the sky. Its impact extends far beyond the realm of military might. The technological advancements made during its development will undoubtedly have ripple effects across various industries, from aerospace and materials science to energy and computing. The flying aircraft carrier is not just a weapon, it is a symbol of human ambition, a beacon of progress, and a powerful reminder of our capacity to achieve the seemingly impossible.